Good morning, students. Today we shall move on to the topic acid, bases and salts. First we shall concentrate on acids and bases. Next we shall move on to salts in the next session. So when I ask a question, what are acids? So what will the answer from your side? Yes, acids are the substances which are sour in taste. Yes, absolutely right what you are telling. But when you look into a chemistry background, how will you say what is an acid? Now let us look into that according to the chemistry background, what actually the meaning of acids. Acids are the substances which release more H plus ions in aqueous solution. So when I say it releases more H plus ions, obviously question comes to your mind is that what are H plus ions? H plus refers to hydrogen ions, means acid contain hydrogen. So that's why whenever an acid is dissolved in water, it releases more H plus ions. So those substances which release more H plus ions in a solution, aqueous refers to water solution, we call them as acids. So acid is the word derived from the Latin word means acidus, which means sour taste. Common examples we can go for acids which are used in our day-to-day life is lemon juice, vinegar, grape juice, etc. Coming to the classification of acids now. As we know, acids are classified into two different parameters. One is the sources, another one is the strength. Sources means origin, from where actually the acids are obtained. So depending upon this category, we can say the acids are as natural acids and mineral acids. Natural acids are those acids which are present naturally in plants and animals. And these acids also contain carbon, so they are also referred as organic acids. Example for these acids are lactic acid, formic acid, citric acid. When I say sources, we should know where actually these acids are present. Lactic acid is present in curd, formic acid present in stings of ants and bees, citric acid present in citrus fruits. Next category of the acid is mineral acids. As name indicate, mineral means they are actually obtained from minerals. These acids will not contain carbon, so they are also called as inorganic acids. Example, sulphuric acid, hydrochloric acid, nitric acid, and moreover these acids are used in laboratories. As I told, another category based on the strength, acids are also classified as strong and weak. So whenever the word strength comes, the two words is very important, strong and weak. So obviously here also we say strong acid and weak acid. What is the meaning of strong acids then? Strong acids means the acids when they dissolve in water, it gives more H plus ions, or it going to ionized more H plus ions. So we call them as strong acids. Example, hydrochloric acid, sulphuric acid, nitric acid. Similarly, weak acids means they are the acids which are release less H plus ions, which are going to ionize to a smaller extent. Examples are H2CO3, which is known as carbonic acid, that is the another important weak acid. Then HCOOH is a formic acid, as I already told. CH3COOH, it is an acidic acid commonly known as vinegar. Carbonic acid, you already know, it is present in the juices like Coca-Cola, etc. That means carbonic acid is nothing but the carbon dioxide dissolved in a gas, which is known as carbonic acid. Coming to the properties, in the properties we shall look into the physical properties. Acids are sour in taste, obviously you know that one. And another important thing, you know that acids when they dissolve in water, it gives H plus ions. But the third property what I am quoting here is that is important because acids are going to show certain changes when they are dipped in different indicators. So indicators includes litmus, phenolphthalein and methyl orange. With these indicators, when acids are dipped, it gives different color solutions. When acids are dipped in litmus come across two categories. One is the red, another one is the blue. When you add acids in a red litmus, we don't find any change. The same acid, when they dipped in blue litmus, it gives red color. Similarly, when acids are dipped in phenolphthalein indicator, it becomes colorless. When acids added to methyl orange, it gives red color. Chemical properties. We shall move on to the chemical properties now. When you look into the chemical properties, we have to look into that how acids are going to react with different reactivity conditions. First of all, when you look into the reaction of acids with metals, what normally it gives? Whenever any metal reacts with an acid, it gives hydrogen gas. And that gas we can see in the form of bubbles. And one more thing you have to remember here is, there is a small activity we have to do here. That is, to confirm the gas is hydrogen, what we have to do? We have to bring a burning splinter or a burning matchstick near the gas. What it will do? As soon as you bring a burning matchstick or a splinter near the hydrogen gas, it gives pop sound. So which tells that the gas is hydrogen. I think this I have discussed already in the first chapter when I discussed. So some of the examples I have quoted here is zinc when they react with acid. The example I have given here is sulphuric acid, hydrochloric acid. When you react the metals with these acids, it gives a respective metallic salts and liberates hydrogen gas. Zinc with H2SO4 gives zinc sulfate with hydrogen gas. Magnesium react with hydrochloric acid, it forms magnesium chloride with the liberation of hydrogen gas. Next, another important property is when acids react with metal oxides, once again it gives salt and water. Example I can quote here is calcium oxide. When they react with hydrochloric acid, it forms calcium chloride, which is a salt, and water. Another important property is reaction of acids with metal carbonates and metal hydrogen carbonates. The very important thing you have to remember here is when an acid reacts with metal carbonates or metal hydrogen carbonates, whether it's a sodium carbonate or sodium bicarbonate, whatever, it gives a gas called carbon dioxide gas. Here it is very important because when I say a first property, I have told the gas is hydrogen, where we have to confirm by bringing what we call the burning matchstick, it gives a pop sound. But here, to confirm the gas is carbon dioxide, what we have to do? We have to pass this carbon dioxide gas to a lime water. So what happens then? When you pass this carbon dioxide to the lime water, it turns into milky. So when it turns into milky, it confirms the gas is carbon dioxide. Why I am stressing these two tests? Because here you are going to see two gases. One is the hydrogen, another one is carbon dioxide gas. So for that purpose, you have to be very careful that either whether it is hydrogen or carbon dioxide, to differentiate whether the gas is hydrogen or carbon dioxide, we have to do this particular test because both the gas are colorless. Next, after you know about the concept of acids, now we shall move on to the next important part of the lesson is the base. So obviously, the same question if I ask you what is a base, then you say that yes, bases are the substances which are soapy to touch. Yes, absolutely right once again. But when you look into as a chemistry background, what is this base then? Yes, bases are the substances once again which are going to release more OH minus ions. So you have to remember this. When I say acids, it is H plus hydrogen ion. When I say OH minus ion in a base, it is called as hydroxyl ions. So whenever a substance is going to dissolve in water, if it releases more OH minus ions, then it is called as base. But how to identify whether it is a base or an acid? Suppose acid, we have to identify by what we call taste or by dipping it in a indicators. In the same manner, we have to base also can be identified by treating with different indicators, or when you just touch a basic solution, it gives soapy touch. That's why the bases are used in soaps. Later we are going to understand that one. Or sometimes if you taste the bases, it is bitter in taste. That is physical test. But if you look into the chemical, we have to go with what we call the reactions or with indicators. Some of the examples for a bases are in NaOH, that is sodium hydroxide, KOH, potassium hydroxide, CaOH twice, calcium hydroxide. When you look into these bases, what will you observe? OH, OH. Commonly you are going to see this particular group. So that is why whenever a compound containing a OH group, we normally refer them as what we call bases. Yes, coming to the classification of bases. Bases are classified based on a parameter called strength. Similarly, when you go into the acid, we have said that the same thing. that is strong and a weak acid, but similarly here also strong base and a weak base. Strong bases means they are the bases which are completely ionized in the water, as you say for acids. If they release more H plus, we call them as strong acid. In the same manner, if they release more OH minus ions, we call them as strong bases. Similar examples for the strong bases are sodium hydroxide, potassium hydroxide. Similarly, weak bases. So same as for weak acids, the bases which release less OH minus ions, we call them as weak bases. Example, ammonium hydroxide, acetic acid, etc. Coming to the properties of bases now. As we discussed for acids, similarly we have to go for bases now. The physical properties of the bases are, first one is they are bitter taste and soapy to touch, yes. A very important thing here we have to remember here is, when I say bases, when they dissolve in water, we have to think very important point here is whether they complete soluble or not. Yes, some of the bases are going to soluble directly, it means they are going to soluble completely in the water, which means they are going to release more OH minus ion. So those bases which gets complete soluble or which going to release complete OH minus ions or which is going to ionize more, we call them as alkalis. We have to remember this word. So water soluble bases, those bases, not all the bases will get soluble. A few bases are going to soluble in water, like sodium hydroxide, potassium hydroxide. So these bases, when they dissolve in water, it gets complete soluble. So we call such bases as alkalis. So another important property is bases dissolve in water to release more OH minus ions. Similarly, when acids are discussed, I have told with different indicators what it gives, what is the behavior. In the same manner, when you look into the bases, bases will also give certain color solutions when they dipped in different indicators. As I told, when bases are dipped in blue litmus, it doesn't give any color. But when it is added to red, it gives blue color. Similarly, when phenolphthalein indicator is added, it gives pink color. And similarly, methyl orange, it gives yellow color. Okay. Next, chemical properties. As you see for acids, similarly bases will also react with certain substances. When bases react with acid, it gives salt and water. This reaction is popularly known as neutralization reaction. We have already discussed in your first lesson. So neutralization is nothing but when acids react with base, it gives salt and water. Similarly, when a base reacts with metals, same thing, it is going to form a respective salt with the liberation of hydrogen gas. I have taken an example of here zinc. Zinc, when they react with sodium hydroxide base, it gives a salt which is known as sodium zincate. The formula is Na2ZnO2 with the liberation of hydrogen gas. This reaction is very important from the examination point of view. Whenever a base reacts with any metal, it gives a respective salt with a revolution of hydrogen gas. And they give most probable question is they are going to ask the question related to zinc metal only. When the zinc is reacted with this particular base, sodium hydroxide, it gives sodium zincate salt. We have to remember the formula of sodium zincate, Na2ZnO2. Next, another important property is with non-metallic oxides, basis is going to give a salt once again and water. The best example I can quote it here is calcium hydroxide. When they react with a non-metallic oxide, is sulfur dioxide, is a non-metal oxide. When that particular oxide reacts with the base, it forms a salt known as calcium sulfite with water. Next, a very important thing we have to remember here is, so as far we have seen, the acids or base, whatever it is, can be identified based on the strength. Just by pouring that one into the water, we can say whether it releases more H plus or less H plus or more OH or less OH. But there is another important parameter where we can able to identify the strength of an acid or a base. So this can be identified by using a scale known as pH scale. Now this pH scale was actually introduced by a Danish biochemist, Sorenson. In German language, the P actually stands for potenz. Now you are looking a picture here which is known as a pH scale, ranges from the number 0 to 14, and you are going to see in different numbers we are going to have a different colors. So whenever the acid or a base is added to that particular what we can say the strip of the paper, we can get different colors. Depending upon the color, we can say the pH what actually the ranges in that particular solution. Now here some of the features we can see in the pH scale. As we know, when you look into the pH scale, the number ranges from 0 to 14. If you get the solutions having the values less than 7, we call them as acids. More than 7, it is a base. So exact 7 is the neutral, neither an acid nor a base. Like this we can categorize the acids based on the values of the pH scale what we obtain. The next important, similar to the pH, we can also have another important thing, that is indicators. Indicators are also another category of the chemical substances which tells you whether a solution is acid or a base. Indicators are also basically colored substances which are extracted from different plants, and sometimes they can also be prepared even in the laboratory. Some of the common acid base indicators, as you already know that one, litmus, phenolphthalein, methyl orange. In addition to these indicators, we are using another indicator which is known as universal indicator. When you just take this universal indicator and add to different solutions, we get different colors. Color is going to obtain. Based on that color, we can say the pH value of the given solution. Now let us look into the table here. What I am already told, here it is there. We can look into the color obtained in different solutions when you add different indicators. When you add litmus indicator to a neutral solution, that is water, we get a color purple. When you add litmus to any acid solution, it gives red color. Similarly, when litmus is added to the base, it gives blue color. So here when red and blue comes, we should look into that which indicate litmus, whether it is a red litmus or a blue litmus. If you add blue litmus to acid, it gives red. If you add red litmus to base, it gives blue. Similarly, phenolphthalein, it gives colorless in neutral solution, colorless again in the acidic solution, whereas in basic solution, it gives pink color. Methyl orange, when it is added to neutral, it gives orange color. In acid, it gives red color. In base, it gives yellow color. Similarly, when you take certain samples of acids, what we use in the lab, for that when you test with these indicators, what color you are going to obtain, let us look into here. Just recollect this. When you add blue litmus solution to an acid sample like HCl, it gives again change to red. Red litmus if you add, it no color as I told already. Phenolphthalein if you add, it gives colorless. Methyl orange if you add, it gives changes to red. Similarly, the same indicators, if you add with different acid samples, you are going to get different color. If you look into the nitric acid, again with blue litmus it gives red, with red litmus no color, with phenolphthalein again colorless, with methyl orange it gives red. When you go for a base like NaOH, again when blue litmus it doesn't give any color, but in red litmus it changes to blue, with phenolphthalein it changes to light pink, with methyl orange it gives yellow color. Similarly, we have another base called KOH, that it gives again the same parameter will holds good for blue and red, but in phenolphthalein it gives pink, again in methyl orange it gives yellow color. So this will tell you that how the color is going to change with different acid samples when you add, or base samples when you add with different indicators. Now I have told we have one more indicator called universal indicator. What is this universal indicator? Universal indicator is a mixture of several indicators. It shows different colors at different pH values, as I already told you. When you add this 1 or 2 drops of indicators to a solution, then the solution acquires a specific color which helps you to tell what is its pH value. Now look into the chart which tells you that. So importance of pH. Now pH is very important in daily life. So where we can applicable this particular pH means, we can see pH in our digestive system where pH plays a very important role. We know that during the digestion there will be more excess of HCl is going to be secreted and causes some irritation. Now this can be reduced by using what we call base. How to get that one? So base means we cannot take direct bases. So base containing what we call antacids we have to take. What are antacids? Antacids are the substances which contain certain bases, and when you take these antacids, they neutralize the pH value in our stomach during the digestion process. So there we can apply the pH here. So pH is also one of the application in our day-to-day life. So you can quote that particular here. Next, another important application of pH is it leads to tooth decay. Very important. So we know that whenever the pH in the mouth falls below 5.5, the enamel gets corroded because the bacteria are acting and becomes what we call toothache. So during that time, so we have to use a base which is going to be get neutralized. So which base we can use? So bases contain toothpaste. We know that toothpaste contain bases. When you use the toothpaste by the time, so they decrease the pH value and also less irritation will be there. So here also we can see how the pH is going to be altered. Yes students, now in this session we have learnt the definition of acids and bases and its properties, and we shall also look into certain indicators, how it plays a very important role in different acidic and basic solutions, and also the pH and how it is going to be important to our day-to-day life. So in the next class we shall discuss some more concept about the acid bases. Thank you students.